Alright, I'm picking up on example 2 because our recording messed up after example 1. This is still objective 26, I believe, and we are finding double angles. So we decided that probably the easiest thing to do, that if you were given the sine is -3/5, let's go ahead and find the cosine and the tangent of each. I'm going to just kind of put this up here so we know all students take calculus. So we know that x is in quadrant 3. So we know that the cosine is going to be negative, and we know the tangent is going to be positive. Okay? And you can fill into sine squared x plus cosine squared x is equal to 1. Because you know that the sine is -3/5 squared plus cosine squared x equals 1. And so when I square that, that gives me 9/25 plus cosine squared x equals 1. And when I move this across and subtract 9/25, cosine squared x is equal to 16/25, and when you take the square root on both sides, cosine of x is equal to plus or minus 4/5, but we know that it's going to be a -4/5 because I'm in quadrant 3. Okay, so I'm going to take the negative. And then you know tangent is equal, you can just take -3/5, you can take the sine and divide it by the cosine. So you know these will cancel, and a negative over a negative is a positive 3/4. Okay, so that's what I would do first, is I would just go ahead, because you know you're going to need to find all of these, you're going to need your sine and your cosine and your tangent. So go ahead and just find them, and then you can just start plugging into the formulas. So if we go to, I'm going to start with sine of 2x first. Okay, and we know the formula says 2 times the sine of x times the cosine of x. So 2 times, we know the sine of x is -3/5, and we know the cosine of x is -4/5. So when I multiply that all together, and you can use your calculator as long as, you know, if there's radicals, then you got to do it by hand. But, you know, if these are just plain numbers and fractions, you can just put them in the calculator, math enter, and it'll give you. So we know the sine of 2x is equal to, a negative times a negative is a positive, and I believe this is going to come out to be 24/25. So we know the sine of 2x is equal to 24/25. Now, someone made a good thought yesterday, and they said, Miss Corns, they said, I thought we were in quadrant 3, meaning that the sine should be negative. Why is it positive? Because you got to remember, these are where we're starting. These are the sine, the cosine, and the tangent. We're starting in quadrant 3. But if I double this angle, let's think about it. Give me an angle that's in quadrant 3. How about 200? Okay. If I double that, that would be 400 degrees. And let's think about where it's going to end if you double it. So all the way around would be 360, and then another 400 would put you in quadrant 1. So it could be that you're in quadrant 3, and when you double it, you end in quadrant 1. Okay. Now, if you took an angle closer to 270 and double it, you would end up all the way in quadrant 2. Okay. So you're either going to end, if you're in quadrant 3 and you double it, you're either going to end in quadrant 1 or quadrant 2. So it makes sense that our sign is positive because we're going to end in quadrant 1 or 2, and in quadrant 1 or 2, the sign is positive when you double it. Okay. So let's go to cosine of 2x, and you can use any of the 3 formulas that you want to. I'm going to use, if we go back I'm going to use cosine squared x minus sine squared x. I'm going to use the first one. Okay, so I'm going to use cosine squared x minus sine squared x. So cosine is going to be negative 4/5 squared minus the sine is negative 3/5 squared. So when I square negative 4/5, I'm going to get a positive 16 over 25. Minus, when I square this, I'm going to get a positive 9 over 25. So that's going to make a positive 7 over 25. So I know the cosine of 2x is equal to 7 over 25. Okay? And then we figured yesterday that you can use the formulas for tangent. That is just fine. But we also figured that we know that sine over cosine is equal to tangent. We also know that sine squared x over cosine squared x is equal to tangent squared x. And we also figured out that sine of 2x divided by cosine of 2x is equal to the tangent of 2x. Okay, so we can just divide here the sine by the cosine, and the tangent of 2x, 25s will cancel, will be 24 over 7. And that makes sense that everything's positive because we just talked about it, that if you started in quadrant 3 and you double it, like I just, for example, took 200 and I doubled it and made 400. If you plot 400, you go all the way around, that's 360, and up just a little bit more, that would land you in quadrant 1, meaning everything should be positive. So that works. Okay, I'm going to do one more example here. So the best thing that you could do is go ahead and find your sine, your cosine, and your tangent before you even start with the formulas. Now we know tangent, if cotangent is negative 1/2, we know the tangent is the reciprocal of that, so tangent is negative 2. The question is how do you find your sine and your cosine? And I would go back to your Pythagorean identities. We know that tangent squared x plus 1 is equal to secant squared x. And so I could put in negative 2 squared plus 1, and I can solve for secant. So that's going to make 5 when you square and add. And when I take the square root of it, it becomes the square root of 5. Okay, that's secant. Well, we know the relationship of secant to cosine is the reciprocal. Okay, and if I'm in quadrant 2, let's think sines real quick. All students take calculus. If I'm in quadrant 2, I know that the cosine should be negative, so this is actually going to be negative square root of 5. So I know the sine's going to be positive. If I take the reciprocal of this, the cosine of x is going to be 1 over the square root of 5, but then I need to rationalize it, and so that's going to make the negative square root of 5 over 5. So negative square root of 5 over 5. Now, you can go back to your Pythagorean identity, now that you know cosine, and you can find sine. So, and there's other ways to do it, but this is just how I'm doing it. I'm going to go back to sine squared x plus cosine, I know, is negative square root of 5 over 5 squared equals 1. So I'm going to square that. When you square square root, those cancel, and you just get 5. This is going to be a plus. Sorry, not an equals. Plus. And you square 5, you get 25. And you can reduce that if you'd like to, and make that 1/5. That would be fine. And I'm going to move this over and subtract 5. Getting ahead of myself. Subtract 5 over 25. And you can use your calculators for this, or find common denominators. You're going to get 20 over 25, and I'm going to take the square root, and so this is going to be plus or minus 4/5. And we want to make it a positive 4/5 because we are in quadrant 2. Okay, so now we're going to go to our formulas. Okay, and I'm going to start with the sine of 2x is equal to 2 times sine of x times cosine of x. So that's going to be 2 times 4/5 times negative square root of 5 over 5. So when I multiply this out, I believe this comes out to negative 8 times the square root of 5 over 25. Okay, so there's your sine of 2x. Okay, let's look at the cosine. I'm trying to think. I want to check something really quickly just to make sure I didn't. I'm going to go back and check my sine. I want to make sure that I took the square root right. So this was sine squared x plus negative square root of 5 over 5 squared equals 1. Sine squared x. Just make sure I didn't make a mistake. Plus, that's going to be, I'm going to make this 1/5. I'm going to go ahead and simplify it this time. Oh, yep, I did, because I forgot to take, I knew I did that. So this is going to make 4/5. And sine squared x. I didn't take the square root of it. So sine of 2x is going to become plus or minus 2 over the square root of 5, but then I need to rationalize it. So that makes 2 square root of 5 over 5. Yep. So, sorry about that. Let me go back and redo. 2 square root of 5 over 5. Okay. Let's go back real quick. Sorry, Miss Corns isn't perfect. Let's go back and find, so this isn't right. I knew that wasn't right. Alright, sine of 2x is equal to sine of x times cosine of x. So 2 times 2 square root of 5 over 5 times negative square root of 5 over 5. So, let's think about this. This is going to make, on top, 2 times 2 is negative 4. And square root of 5 times square root of 5 is just 5 over 25. So that's going to make negative 20 over 25, which reduces to negative 4/5. That looks better. Okay, so let's go to cosine. And cosine of 2x, I'm just going to use cosine squared x minus sine squared x. So negative square root of 5 over 5 squared minus 2 square root of 5 over 5 squared. So that's going to, when I square root, they cancel, and I get 5 in the numerator and 25 in the denominator. When I square this, 2 squared is 4. Square root of 5 is 5, so 4 times 5 would be 20 over 25. So that's going to make negative 15 over 25, which becomes negative 3/5 when you reduce it. So cosine of 2x is equal to -3/5. And then, if you know your sine and your cosine, you can just divide them. The 5's will cancel, and a negative over negative is a positive, and you get 4/3. So there is your answers. Now, if the tangent's positive, that means we started in quadrant 2, and let's think about this. Let's take a 100-degree angle. When I double 100, I get 200, right? So where's 200? 200 lands in the third quadrant, and that makes sense because my tangent is positive and the other two is negative. So you might start in one quadrant, but once you double it, you're going to end in another quadrant. So that works. Okay, so hopefully you have enough to go by.